Howdy!
Howdy!
We are Team Awesome. I'm Andre. This is Steven. This is Long. This is Gustavo. And today we will be talking about disasters in engineering. The future is now. We're already living in it. Whenever you want any access to any information, all you need to do is look in your phone. You have an infinite library of endless knowledge available at your fingertips. We've come such a long way with these advancements in technology that it's kind of hard for us to really realize how far we really made it. 60 years ago, before the first manned space flight, we did just invented the airplane. So there's really no telling where we're going to go in the future, how far we can take it. And one thing that we really need to pay attention to is that the greater the engineering feat that we like to accomplish, the bigger the risks. And these risks can be not just monetary, but they can also be people's lives. Take it away, Long.
So the first disaster we're going to talk about is the Skylab in 1973. The Skylab was the US first main space station. It's used for Earth observatory. Also, proof that US can also having a working space station. On the launch day, everything was checked fine. Everything was carried on, but only after 63 seconds later, a disaster happened. One of the meteor shield was prematurely deployed, and it hit one of the solar panel, which ended up reducing the energy of the whole system. So they have to rotating the ship into the sun to get more energy, but that ended up overheating the whole space station. So what do we do to fix this? We have 10 days to plan for it and get 3 crew of 3 astronauts. Each have to come up there just to fix instead of researching. This end up requiring a lot of manpower, a lot of money, and a lot of equipment. But this mistake wasn't bad, and was bad, but it wasn't too bad because there was no human life taken. What happened if there's a human life involved into this situation?
Yeah, like my classmate Long said, the Skylab was a really bad experience, but in the end, nobody died. They sent some crews, and there was just a monetary loss. But with the Space Shuttle Challenger, is really another thing. So on January 22nd, 1986, the Challenger was supposed to launch, but due to some problems, they moved it back, and ended up being moved back every other day, and until January 28th. On the day of the launch, the night before the launch, it got below what they call the red line, that for how cold it should be before launch. So how cold it should be before launch, and they shouldn't launch it because problems that cold may cause to the space shuttle, and they decided to launch it anyways. So this caused an armoring to fail on the shuttle, leading up to the fuel getting to catching fire and making the aircraft explode, and leading up to the death of the 7 crew members on board. But the problem about this is that this could have been prevented because there were engineers telling not to launch this space shuttle because of the cold and because of all the problems that it may come with. So yeah.
And so where do we go from here? Where do we go as a society of engineers after some type of catastrophe like this happens, where people lose their lives or we lose monetary value, sometimes even in the millions? What are we supposed to do to deal with those kinds of problems? we help each other. And we do that through double checking each other and setting up standards for how we operate and do things. We come up with systems and checks for each other so that people don't lose their lives and that people don't lose money. And if there's a problem, we can address it then. And more importantly, we listen to each other and double checking each other's work. Because at the end of the day, you could stop a catastrophe from simply going over somebody else's things or work and preventing something like this from happening. And we establish safety standards by rules and regulations established either by governments or companies themselves, like major changes in NASA after these accidents that really we shouldn't be blowing off engineers, and that we should really understand why things need to be as specific as they are. And at the end of the day, you have to work as if your life was on the line as well, because it could be. And the people around you could also be affected as well. So be safe, y'all. Cut.